Now I'm going to present the main simulation tool we're going to use in this course. It's a 3D simulation of an indoor environment of a drone based on a known open source simulation named AirSim, provided by Microsoft, and we've adapted to be able to add more controlling algorithms and more robotic algorithms as a tool for our course. I'm in a manual mode and I'm taking off. I want to maintain my height. It's quite tricky because I need to go upwards and then stop and downwards, and you see I'm kind of bouncing. I'm doing this kind of a sinus maneuver with respect to my height. And if I push too much, I go too high, going all the way too high, and then I'm bouncing back. So obviously in this simulation nothing happens, but in real world that might be an issue. So now let's move to an algorithm, and now the drone maintains its height perfectly. It's roaming around the entire simulation environment, and now you can see in a kind of a pinkish trail the movement of the drone, and it used some sort of algorithm in order to do that. And let's see how it works. So it's going around in a certain height, say 1 meter. In green you can see the little dots, which is the input for the drone. It's actually measuring of distance, forwards, backwards, left, right, up and down. That's it, as if it was this drone. And it's keep doing, and in a way you can see it's basically try to go and explore the room. Now you may think there's a door, an open door, that the drone might go outside, but in this algorithm what it's going to do, it's going to keep staying indoor, because going now towards the place where there's an open door to its right, it also has an option to go left, because this being like over 4 meters seems like infinity. Therefore the drone is in a way favoring going left, so it will circle itself in the same manner, and we can keep doing that. Obviously it's not the exact same track because we put some randomic parameters with respect to its position and its measuring of the distance from the walls, but altogether it will keep circling. Now if I change the algorithm to maintain a certain distance from just a single wall, the algorithm is quite different. It's a little bit, few parameters were tweaked, and now it only maintains a certain distance from the right wall. So you see it maybe bounced more, but going to now when it has no right wall, it will turn right and start looking for a right wall. So changing the mode by few parameters, that instead of looking and try to balance itself left to right, just balance yourself rightward. Change the way the drone has solved this kind of puzzle or this maze, and changes its track altogether. Now you may think that in some cases maintaining the right wall will be an optimal way, and in some other cases maintaining both safety distance between two walls is the way to go. And actually the most intelligent thing to do is to decide in my objective function, in my state machine, in more accurately defined, to decide in my state machine when I should move to one state to another. And being able to know when should I maintain a certain distance from one wall and then maybe move to another wall will allow me to explore this entire region and avoid those kind of endless loops. To summarize, In our state machine, we have few states. Some of them are trivial, like on the ground, take off, land. The others are more complicated, and the main intelligent issue is, when should I move from one state to another? What is my state changing function? In some cases, you want to use maintaining just the right distance from your white wall. In the other cases, I want to change my mode to balance between two walls. And in some other cases, maintaining a certain distance from my left wall would be a right way to go. Deciding which mode should I move is actually the main AI problem we're going to tackle and address in this course.